Hello, everyone. Welcome back. Today, we're going to be solving radical inequalities. We'll be solving these three radical inequalities. All right. So the first one is the square root of x plus 5 is less than 3. So the first thing we are going to do to solve this inequality is we are going to square both sides. So if we square both sides, we end up with the square root of x plus 5 squared is less than 3 squared. Now, the square root of x plus 5 squared is a term where the square root and the squared are going to cancel each other out. So we're going to get x plus 5 on the left. On the right, we're going to simplify 3 squared and say, well, 3 squared is just 9. So that means x plus 5 must be less than 9. Then we're going to subtract 5 from both sides to get that x must be less than 4. Now, before we're done, there is one more thing we need to consider because it's a square root. We know that we cannot have anything in the square root sign that is less than 0. So we also know that x plus 5 must be greater than or equal to 0, because the second that x plus 5 becomes less than 0 is the second that it becomes a negative number, and we can't have a negative number in our square root sign and get a real answer. We'd get a complex answer then. And so what we're going to do is we're going to solve this. We're going to subtract 5 from both sides, meaning that x must be greater than or equal to negative 5, because the second it goes a little bit less than negative 5, then that's the same second that this term here becomes undefined, because that's when we are going to get a negative overall under the square root. And so therefore, the final answer for this one is that x must be between negative 5 and 4, including negative 5, but not including 4, right? Because notice that here we have a strictly less than sign in our original inequality, but in the new inequality that we made, we noted that having x plus 5, which is what's under our square root, be equal to 0 is okay, because square root of 0 is defined, it's 0, so that's okay. But having it be, having it be less than 0 would not be. And so that's important to keep in mind, that this one here is less than or equal, and this one is just less than sign. All right, let's try another one. Here we have 2x minus 1 in under square root sign is greater than or equal to 5. So same thing here. I'm going to start by just squaring both sides. So if I square both sides, I get 2x minus 1 is greater than or equal to 25. Then I'm going to add 1 to both sides to get that 2x must be greater than or equal to 26. Then I'll divide both sides by 2 to get that x is greater than or equal to 13, like that. And then I'm going to need to figure out what values are valid for under our square root sign, because again, under the square root sign must be greater than or equal to 0. So that means 2x minus 1 must be greater than or equal to 0. Now, if we add 1 to both sides, we will note that that's the equivalent of 2x being greater than or equal to 1. Then if we divide by 2 on both sides, we get that x is greater than or equal to 1/2. Now keep in mind that every number that is greater than or equal to 13, automatically, if it's greater than or equal to 13, then it also must be greater than or equal to 1/2. Now the same is not true the other way around. Just because something's greater than or equal to 1/2 doesn't necessarily mean it's greater than or equal to 13, but all numbers 13 and up are also greater than or equal to 1/2, right? Well, specifically greater than 1/2, right? So therefore, the final answer is just x is greater than or equal to 13. We actually don't need to include this anywhere, because automatically, if this is true, if it's true that a number is greater than or equal to 13, then automatically we know that the second condition of it needing to be greater than or equal to 1/2 is already met anyway. Okay, let's do number 3. So for number 3, I'm first going to start by adding 2 to both sides to get the square root of x plus 1 is equal to, is not equal, it's less than or equal to 2. Then I'm going to square both sides to get x plus 1 is less than or equal to 4. And then I'm going to subtract 1 from both sides to get x is less than or equal to 3. Okay, so that's our first part, right? We know that in order for this to be true, x must be less than or equal to 3. And let's see if there's anything else x must, that restricts x in any way due to the fact that there's a square root in our original expression. So I'm going to figure out when is it true that x plus 1 is greater than or equal to 0, because that's what must be true as well. In this case, if we subtract 1 from both sides, we get that x must be greater than or equal to negative 1. And so there we go. Okay, now let's put it together. We know that x must be less than or equal to 3, and x must be greater than or equal to 1, or sorry, negative 1, rather, greater than or equal to negative 1. And so the final answer is that negative 1 and 3 are the bounds. So there's our final answer for that one. As always, feel free to leave any questions in the comment section, and we'll see you for the next one.